Hey everyone, welcome to homework 4.11. So I'm going to actually start this video by going over what we've been reviewing. And so when we have a quadratic function, it has several important points, right? It has our x-intercepts, which is where it crosses the x-axis. That means for these points, the y is always going to be 0, right? Because we haven't gone up or down off of the x-axis. And so when we're looking for those points, we know that y is 0 and we need to solve for x. And that's why when we have, for example, f of x equals x minus 2 times x plus 3, we can set these to equal 0. Because what we're really doing is saying, well, when does y equal 0, right? And when y equals 0, then if we were to solve for just x, we would divide by this. And we would then have x minus 2 equals 0, because 0 divided by anything is 0. And so then we can add 2 to both sides, and we get x equals 2. So we know that for one value, it's 2. And then we can also then solve for the other x. So we can say x plus 3 would also equal 0, because if that happens, then this whole thing would be 0, because it's multiplying by a 0. So I'll subtract 3 on both sides, and we get x equals negative 3. I'm showing you the step because even though many of you can do it mentally, I want to make sure that you have reviewed it and that you remember how to do these two-step equations appropriately. Oh, I did not mean to open that email, excuse me. All right. Now, move it faster to make it bigger. Oh, cool. Okay. This is a new tool I'm using, so it's very exciting. The other thing that we looked at today was finding the vertex of a quadratic given the x-intercepts. So if we have x minus 4 and then let's say x plus 6, right? Let's say that this is our quadratic. All right. Well, now we know that one x-intercept is 4, and we know that the other x-intercept is going to be negative 6. So this is going to be a fairly rough sketch here, but 1, 2, 3, 4, 5, 6 here. So these are the 2 points. So now if I want to find the vertex, I know that the vertex is right in between, or in the midpoint. The x value is the midpoint of these two values. It should fall right in between these two. So what I'm going to do then is we can add 4 plus negative 6. That negative still has to stay, and then divide by 2. And what will end up happening is we will get 4 plus negative 6 is negative 2, divided by 2 is negative 1. This means that the x value of my vertex will be negative 1. And so it's going to fall somewhere on that line, right? In between. And if we check that, we can see that this is 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 away. And so they are, in fact, equidistant. So now we know that the x value of my vertex is negative 1, but we need to figure out how far up or down it is, or in other words, what the y value is. So to do that, let's take a look then at if we have x minus 4 times x plus 6, and we know that the x value for my vertex is negative 1, I can plug that value in for any value of x and solve for y. So let's do that. So negative 1 minus 4 times negative 1 plus 6 equals, this is going to be negative 5. And then note that this is multiplication. So 5 times 5 is going to be negative 25. So we have a negative times a positive. Oops, moved that. I need to do that. Okay. And so that means that it would be negative 1 comma negative 25. Well, it's going to be all the way down there somewhere. If I count by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, it would be here-ish, okay? So I'm assuming then you would need to label that you're counting by 2s here, but 1's on the x-axis. That's not a perfect situation. But then you have, right, what your graph would look like more or less, and it is perfectly symmetrical across what is called the axis of symmetry, and that's why we can use that negative 1 to find out what the vertex would be. When x is -1, then y is -25. When x is 4, y is 0. When x is -6, y is 0. The other point that I can use to make this graph even better is to use the y-intercept, which if we FOIL this, or we multiply this and distribute, we'll get x squared minus 4x plus 6x minus 24. We can combine these two terms, but to find our y-intercept, we really just need to look at this constant. And so that would be right above, right at the 24, and that makes sense, okay? That looks like it fits perfectly. So it's just a little bit of a review in case you were still needing to practice how to do that. Let's take a look now at the actual homework. So, oops, that is not the correct homework. Sorry. Here we go. All right. So in homework 4.11, it says select all true statements about the graph that represent y equals 2x times x minus 11. It says its x-intercepts are at -2, 0. And 11, 0. Well, let's see. So you saw one of these actually in the class routine. Somebody started to get confused. 2x is a factor. So we're going to look at 2x equals 0. And then we're going to look at x minus 11 equals 0. Well, x equals 0 then here, and x equals 11 here. So we have 0, 0, and 11, 0 as our points. So B is true. We can then eliminate A and C, and we can go ahead and look at, it has only one x-intercept. That is not true. It would actually cross through the origin as well because it is multiplied by this 2x here. The x-coordinate of its vertex is -4.5. Well, we have 0 and 11, so remember to use our midpoint formula, we're going to divide by 2, add them and divide by 2, which would give us 5.5. Okay? So, and notice it's a positive 5.5, and so the x-coordinate of the vertex would be h. These are all about the x-coordinate of the vertex, and none of those are correct, so h is our best answer here. All right? Number 2, select all equations whose graph have a vertex with x-coordinate 2. All right, so we're looking here for a vertex with x-coordinate 2. So if we add, right, this would be 2, 0, and 4, 0. The midpoint between that would be 3, 0. So that vertex, this is a vertex of 3. Here we would have 2, 0, and 2, -2, 0. If we add those together, you might recognize immediately that the midpoint would be 0, because 0 is directly between 2 and -2. Here we would have 1 and 3. If we add those together, we get 4. 4 divided by 2 is 2. So C looks like a possible answer. Notice it says select all equations, so I'm going to keep looking at all of them. And this one would also have 0 and 4 as the x-coordinates, or the x-intercepts. And so the midpoint between 0 and 4 is 2, so that also works. And here, oh, actually, nope, I'm sorry. Scratch that. This made a mistake because it's positive 4, so this would be -4. So this would be -2. But this one would be 0 and +4, so the midpoint between those would be 2, and therefore the vertex would have an x-coordinate of 2. Determine the x-intercepts and the x-coordinate of the vertex of the graph that represents each equation. So x-intercepts, we're going to set each one to 0, so that means one of them is 0, 0, and the other one is going to be 2, 0. If it helps you to see it, we would do x minus 2 equals 0, add 2 on both sides, we get x equals 2, so we know that's one of the x-intercepts. The x-coordinate of the vertex is the midpoint between 0 and 2, so 0 plus 2 divided by 2 is 2 divided by 2, which is 1. So 1 is the x-coordinate, but then I need to plug that in to find out what the y value is so I can give the full vertex. So 1 times 1 minus 2 equals 1 times -1, which is -1. So this would be 1, -1 is our vertex. All right, let's look at the next one. So for the next one, if we were to look at each of these, we're going to look at x minus 4 equals 0, add 4 to both sides, so x equals 4, x plus 5 equals 0. Subtract 5, so x equals negative 5. So our two x-intercepts are 0, comma 4, and 0, comma, nope, I wrote that wrong, sorry, 4, comma 0, and negative 5, comma 0. And so to find the x-coordinate of the vertex, we're going to add these two. So 4 plus negative 5, that negative is important, divided by 2. And so for this one, we're actually going to get negative 1 over 2, which is negative 1/2. So my x-coordinate of the vertex is negative 1/2 or negative 0.5. And you can write that however you'd like. Whether you prefer to do it in fraction or decimal is not important to me, okay? As long as you know what it is. And then the vertex, then I'm going to need to substitute and plug that in here. So I'm going to put negative 0.5 minus 4 times negative 0.5 plus 5. We will get negative 4.5 here, and then this will be times positive 4.5 here. So you might need to have your calculator handy for that, but you can go ahead and find that value. You might even recognize what 45 times 45 is, and therefore know what that would be. But notice that 1 is negative, so you should have a negative answer. So, oops, excuse me. So you know for your x value here, it'd be negative 0.5. And then you need to figure out, well, what would that y value be? And you'll get that there. So I'm expecting to see you do that calculation. All right, let's take a look at the next one. All right. So for this last one, similarly, we can set each factor to 0. So I'm going to look first at negative 5x equals 0, and then 3 minus x equals 0. Notice this one is a little bit tricky because of where they have the 3 and the x. Okay, so let's take a look at it. Divide by negative 5 on both sides. We get x equals 0. You could probably recognize that one already. So one of our points is 0, 0. The origin again. Now here, there's a couple ways that you can handle this. So we can subtract 3 from both sides. We'll get negative x equals negative 3. But then that's just x equals 3, because we would divide or multiply by negative 1. You can also, alternatively, with this kind of problem, we can add x to both sides. And you would get 3 equals x, or x equals 3. So either way, you get the same answer, and you know that 3, 0 is your other point. Well, then we're going to find the midpoint between those to find the x-coordinate of the vertex. So we're going to add those x values and divide by 2, which gives us 1.5. So 1.5 is our x-coordinate, and then same thing. You're going to plug that in to your equation. So instead of x, you're going to put 1.5. So negative 5 times 1.5 times 3 minus 1.5. And then you're going to go ahead and proceed with that calculation. So negative 5 times 1.5, we're going to do inside the parentheses first. That's going to be 1.5. And then you can go ahead and mathematically solve that, right? So we're going to have 1.5 comma whatever you get for that y value. Now, you can always check your answer by looking at the calculator. So let's take a look at the calculator real quick on this. All right, so in my calculator, I have put already the last equation, just so we look at this one here. Now, if you wanted to distribute it and write this as negative 15x plus 5x squared, you could do that as well. I wrote it just as we had it given to us to show that that works as well. So if I press graph here, now I can see what my graph looks like. Now there's a couple ways that we can evaluate where the zeros are and where our vertex is. Since we know that we're looking at from our classwork, or from our homework rather, we have some idea of where this is. You can also press second table, and we can look for anywhere that y is 0. So here y is 0 where x is 0. So we know that it does pass through the origin. And then we also have where y is 0, x is 3. So that's our other x-intercept. And then you would know that in between that would be 1.5, right? So here you can't see that, but you can go to second table set. And instead of change of table being 1, you can make that 0.5, half. Let's go back to second table. And now we can see these going up by half. So at 1.5, which is the midpoint between 0 and 3, it's negative 11.25. And so that's just one way that you can calculate that. Let's take a look at the graph again. And then the other way that you can do this is, let's go ahead and zoom, let's change our window just a little bit so we can see a little bit better. Let's make this my x min negative 15, because I think it's going to go down to about there. And then I don't need, oh, sorry, that's y actually. So let's actually make this negative 2. We can move it over a little bit. 10's fine. This is negative 15 in our y min. Let's see how that looks. So now we can see this a little bit better. It's a little bit more zoomed in. So I'm going to go to second calc, and let's find here the minimum, because it's the bottommost point for our vertex now. So left bound, let me find my cursor. Where am I? I think that's too far. We gotta go the other way. There it is. Okay. I'll move it all the way to the left side of the curve. And I'm going to enter, and then I move to the right side of the curve. Hit enter, enter, and we get negative 11.25 with a x value of 1.5 approximately, right? Now, I can also find my zeros by going to second calc and choose number 2, 0. In this case, I'm going to go to the left side of my first 0, hit enter, then move to the right side. And the closer you are, the more accurate this is going to be. So you can see 1, 0 is 0, 0, and then I can find the other 0. I'm going to scoot over here. Say enter, and scoot to the right of that other one. And we have 3, 0. Okay, so it's a way you can check your answers in the calculator as well. All right, so let's shift back, excuse me, to the rest of the homework. Number 4 says, which one is the graph of the equation? And so here we can check that by finding our x-intercepts. So x minus 3 equals 0, x equals 3 is one of the x-intercepts. X plus 5 equals 0, x equals negative 5 is the other one. So I'm looking first for those x-intercepts, and then we can check the other pieces if there's more than one that has that. So negative 5 and positive 3. So this one is negative 5 and negative 3, so we can eliminate that one. This is 3 and positive 5, eliminate this one. Then we have, this is negative 5 and positive 3. So that one looks pretty good. Let's check D though. It says negative 3 and positive 5. So that is not true. So it is this one right here, graph C, because we see we have negative 5, 0 and 3, 0 here. All right. Number 5. What are the x-intercepts of this graph? So again, x minus 2 equals 0, x equals 2. That's one of them. X minus 4 equals 0, x equals 4. That's the other one. So we're going to have 2 and 4. It's going to be a very skinny little graph. 2, 4, 6, 8. Yeah, that looks good. Find the coordinates of another point on the graph. Show your reasoning. So I don't care which one you choose. One easy one would be, we can look at this in standard form, and we can see that the y-intercept would be 8. This is going up by quite a lot, so that'd be like here, right? We can also look for the vertex. So we can say, so one is 0, 8, and you can show your reasoning using the standard formula that gives you the y-intercept. We can also look at our midpoint of our x-intercepts. It should be 3, so that would be in between. And then we need to plug that back in to find the rest of the vertex. So you would do 3 minus 2 times 3 minus 4. Oh, terrible things have happened. Okay. Where was I? 3 minus 4, right? So that's 1 times negative 1, which is negative 1. So that point would be 3, negative 1, that would be right below here. So this graph would be on this scale pretty wide looking because of the scale on the y-axis. All right, but that would be your graph, more or less. Okay, again, it's kind of a weird looking graph, but so you could also have 3, -1 as your vertex, showing your reasoning using your midpoint formula and then plugging that in to find out what y equals. All right, a company sells calculators. If the price of the calculator in dollars is P, the company estimates it will sell 10,000 times 120p calculators. Write an expression that shows us the revenue. So this is just going to be this. Right, we're multiplying the price times how many calculators they think they can sell. Which, incidentally, some of you asked, well, what is that? Who determines this formula, right, or this calculation? And I told you that there's people whose jobs that is for them to do. There's a couple people whose jobs that is. So one, this is about revenue. So there's actually something called a chief revenue officer. They might be doing the research around this. Someone who does revenue marketing or is a revenue marketing manager, that would be their job to do the research to determine this formula, usually based on previous ticket sales and data and research they're going to do. So just as a side note for that. Is S plus T all squared equivalent to this? Explain or show your reasoning. So we're going to do this. So remember that when the square is outside of the parentheses, that means everything is squared. So we have to square S plus T times S plus T. And so let's go ahead and do that. Now you can use your box method if that is easier for you. Again, these are all positive, so this is a nice, easy one to do. And then something to note is that if you have a variable times a variable, for example, x times y, that's just xy, right? That indicates that these are being multiplied. And then this would be s times t or t times s. Those are interchangeable. So we'll get s squared, right? If we do this, and then plus s times t, and then plus t times s, or plus s times t, and then t squared. So this is actually going to be s squared plus 2st plus t squared. All right, Tyler is shopping for a truck. He found 2 trucks that he likes. One truck sells for $7,200. A slightly older truck sells for 15% less. How much does the older truck cost? So this is a very simple mathematical piece that we're working on here. And so we could multiply by 15% and then subtract that from 7,200. Or we know that if it's 15% less, it's only 85% of the cost. And so you can calculate this on your own. Number 9, here are the graphs of 2 exponential functions, f and g. The function g, f is given by 100 times 2 to the power of x. G is a times b to the power of x. Based on the graph of the function, what can you conclude about a and b? So f of x is the blue line here. G of x is the red line that goes underneath of it. So that means that for g of x, a is less than 100 because that starting point is underneath the blue line, or f of x. We can also conclude that g eventually outgrows f, and that means it has to have a higher factor. So we also know that b is greater than 2. And that's it. That's all we conclude from this because we don't have any actual numbers on this graph. All right, suppose G takes a student's grade and gives a student's name as the output. Explain why G is not a function. So the reason this is not a function is because putting in a grade as an input could produce multiple results. Example, if I put in 99 as the grade, there could be multiple students with that grade. Okay? All right, your code word for today will be revenue. Revenue is your code word because I looked up that job position for you. And then I'm going to go back to the classwork. So if you are good on the classwork and you don't need my help, you can stop here. If you need my help, then you can stay with me. I'm going to go over 11.3, and then I told you you didn't have to do the are you ready for more and the next part, so I'm going to skip that and go to the last part. All right, so the functions f, g, and h are given predict the x-intercepts and the x-coordinate of the vertex of each function. So the x-intercepts, we can set each to 0. So, oh my goodness, here we go. All right, so x plus 3. Oh, bad things are happening. What's going on? Okay, hold on. Let's let the computer settle down for a second. No, it just doesn't want to. All right. Well, x plus 3 equals 0 is how you would set that up. So we would subtract 3 from both sides, which would give us negative 3 as 1. And then the other one would be 5. Because we would do x minus 5 equals 0, add 5 to both sides. I don't know what is going on, but it's doing lots of things. Give me a second. Let's figure this out. Okay. Save you. Calm down, computer. Okay. So the x-coordinate of the vertex, remember, we're going to add the x values of our x-intercepts and divide by 2. So this would be 2 divided by 2, which is 1. And then it says... down below, use graphing technology to graph them and use the graphs to check your predictions. So we're going to graph this in our calculator. Let me clear this out. So this would be x minus 3. Actually, let me make sure I remember. Oh, x plus 3. See? Nope, didn't remember correctly. X plus 3 times x minus 5. And then we're going to do graph. Okay, now mine was already set up to an interesting window, so I'm going to change it to standard. And then it's still a little bit low here. So let's go ahead and do window, and let's change our y min to something lower, so negative 20. And let's see how that looks, graph. That's a lot better. So now I can see these more clearly. So let's take a look, second calc. We're going to use find a 0 here. And you could just trace and kind of figure out, okay, does this look like it's at negative 3? Is my answer correct? And, you know, you can reason out that it is. Say enter, guess, and it is negative 3 comma 0. You can do the same thing for the other 0, and then we can do the same thing for the vertex by doing second calc. And here, again, we're going to do minimum because it is the lowest point on this graph. Our vertex is the lowest point this time. So to the left bound, set a boundary on the right, hit enter, and it's going to guesstimate, and it says 1.000011 with a y value of negative 16, and we did in fact say that our x-coordinate of the vertex was 1, so this is correct. Okay? Here, again, this is a factor, so you're still going to set 2x equals 0, and then x is going to be 0, so one of your x-intercepts is going to be 0 comma 0, and then the other one will be x will be 3 comma 0, where the x is 3. And so for our x-coordinate of the vertex, we would do 3 plus 0 divided by 2, and that's going to give us 1.5. And then we are similarly, you can go into your calculator and graph to confirm. Now, if you're at home and you don't have your TI-83 with you for some reason, that's okay. You can also do this on Desmos and analyze it there. I'm fine with that if you're stuck for a graphing calculator. The only thing I just want to note is that if you do this on Desmos, Desmos is different than your calculator that you're actually allowed to use on the test. So just keep that in mind. Oops. Okay. All right, so that gives you a graph here. And notice that in Desmos, it's a lot nicer. You can see those x-intercepts immediately, and you can see that this is your solution for your vertex without doing all that other calculating. So if you want to use Desmos to check your answers, I'm fine with that. I just want you to keep in mind that this is not the tool that you will have on the test. And so it's important that you know how to do it on your TI-84. Okay? All right, so those are a couple examples from that and what I would like you to do. It says, without using technology, sketch a graph that represents the equation y equals x minus 7, x plus 11, and show the x-intercepts and the vertex. So this would be x minus 7 equals 0, so x equals 7, that's 1, and the other one would be x equals negative 11. So we can go ahead and plot that point, be here, nope, negative 11, sorry. Negative 11 would be here, and positive 7 would be here. So those are our x-intercepts. And then 7 plus negative 11 divided by 2 is negative 4 divided by 2, which is negative 2. So that would be right here. So what I'm going to do here is draw my axis of symmetry rather than my actual point, because I don't know what it is yet. I just know that x equals negative 2. So now I need to plug that into my equation. So negative 2 minus 7 times negative 2 plus 11 equals negative 9 times 9, which is 81. So that's why it goes all the way down to 80 here. So it would be just below this 80 mark that my vertex would be. And so then I can draw my vertex. Now I also know that my y-intercept would be negative 77. So we can estimate that that would be about here, just to give us another guiding point. And you'll have a symmetrical point on the other side of the graph, right? Anything, the parabola is symmetrical, so it should match what's on the other side if you were to fold it over as a reflection. All right, so I told you can skip this. I'd like if you did it. It's good practice, but if you feel confident, you can skip it. And then you're going to do 3 from here. So you can pick any 3. The difference between these is that you have some coefficients, so you need to do a little bit more work to find your x-intercepts. Let's start with this one since this tripped you up a lot. This is the same as 2s minus 3 times 2s minus 3. So problem 10 is the one I'm choosing to do. Now notice these are the exact same, so the x-intercept is going to be the same, which means there's only going to be one x-intercept. And so here we would do 2s minus 3 equals 0, 2s equals 3, s then equals 3 over 2. So we have 3 over 2, or 1.5, comma 0. And then the y-intercept here would be positive 9, 0, comma 9. And I know that because if I were to put this in standard form, that's what I would get. I can also say if I plug in 0 for s, I would get negative 3 times negative 3, which is positive 9. And then the vertex here, my x-intercept here is interesting because it's only one x-intercept, right? And so we would do 0 plus 0 divided by 2 is 0. And so the vertex that you're going to get is going to look like 0, comma 0. But let's check and see, because that is not going to be possible either. So let's put it into, we'll go ahead and put it into Desmos since I have that open. 2x minus 3. Did I do the right? I did. Okay. All right. So here we can see that here is 1.5 comma 0 is our vertex. And then notice that is also our x-intercept, right? Because there is only one, that is also our vertex and our x-intercept. And then we can go up here and see that, yes, in fact, 0, comma 9 is my y-intercept. Okay, so here the vertex is going to be 3.2, comma 0. Again, because there's, again, only one x-intercept, and that is your vertex. All right. Let's go ahead and try, let's do 13. So for 13, we would do 2y minus 1, or plus 1 equals 0. Subtract 1 from both sides, so you're going to get y equals negative 1/2. And so one of your points is negative 1/2, comma 0. It's a little confusing because they use y here. I'm sorry about that. 4, comma 0 is your other one. And so then your y-intercept, we can see here, would be 0, -4. Your vertex then is going to be the midpoint between 0.5 and 4. So this one might be, you know, a little bit more complicated too. 4 plus -1/2, which is 3.5 divided by 2. Okay, so you're going to get a little bit more complicated of a number in this one, where we have 3.5 divided by 2, and we get 1.75. So 1.75 is the x value for that, and then you would need to go back in and plug that in here to see what you get for y. So 1.75 times 2 plus 1 is 4.5 times 1.75, excuse me, minus 4 is minus 2.25. Okay, and so that times 4.5 gives us negative 10.125. And again, if you want to, you can check that in your calculator or in Desmos to make sure that looks right. 2x plus 1 times x minus 4. And I don't know why it doesn't like the way that I'm doing from, there we go, my parentheses, but there you go, there you have it. And you can see here we have -5, 0, 4, 0, and 1.75 and -10.125 as an answer. Okay, so you can check it using Desmos if you like. Just make sure you know how to also do it in your TI-84, and then select a third problem for you to do. All right, any questions, feel free to reach out. Happy homeworking and see you tomorrow.